All right, guys, here is 6.6 homework. Before we do 6.6, I want to review what we talked about in class. Proportionality is when all you have to do is multiply by a number to get from the input to the output, which means if I put something in my machine, the only thing that happens inside that machine is multiplication. No addition, no subtraction. So when I put something in, if all I do is multiply, then it's proportional. Here's how you tell if it's a rule, looking at a rule, a graph, or a table. Rules. It will only have, look, if I cover this up, if it only has this first part, if it only has multiplication going on, then it's proportional. If I put something in this machine, it's going to be multiplied by 3, and that's it. So that's proportional. If I put something in this machine, it's going to be multiplied by 3 and then subtracted, or subtract 2. So that's not proportional. So when you put something in this machine, it gets multiplied by 1/2, so that is proportional. If I put something in this machine, it gets multiplied by -1/2 and then added to -6. That's not proportional. So that's how you can tell if it's a rule. Let's take a look at if it's a graph. A graph will always go through 0, 0. It will always go through the origin, no matter what, if it's proportional. If it hits anywhere else above the origin or even below the origin on the y-axis, then it's not proportional. Here's how you look at a table. We're going to take this idea and take it over here. Both of these ideas are apparent or seen in the table. First, take a look what happens inside this machine. If I put something in this machine, the only thing that happens is it gets multiplied by 3. If multiplication is the only thing that happens inside that machine, then it's proportional. Also, it always goes through the origin. The address of the origin is 0, 0. This has 0, 0. So that is proportional. So now let's take a look at not proportional. If it goes through 0, 3, 0, 9, 0, -5, 0, anything that's not another 0, then it's not proportional. If this was 0, 3, it's going to cross at 0, 1, 2, 3. So it would cross way up here. So that's not proportional. All right, so let's go ahead and get through 6.6. Okay, so it says the values in the tables represents points on a line. Let's go ahead and, before we even try to answer these questions, let's say if these are proportional or not. Look here, 0, 4, so that's not proportional. 0, 0, so yes, that is proportional. 0, 7, not proportional. 0, 0, proportional. Okay, well that was easy. Now let's see if we can answer some of these questions. Which table represents proportional relationships, where you can just multiply by the input value to get the output value? Well, this is proportional, that was B, and this is D, so those two are proportional. Because watch, all you have to do is multiply by 7 to get over to the output. All you have to do here is multiply by 2. So proportional means only that multiplication is happening. Which table represent the relationships that are not proportional, where you can't just multiply to get out the output? So we have A is not proportional, C is not proportional. Graph the points from the tables. Draw a different dotted line through each set of points and label with A, B, C, or D. Well, if I take a look at all of these, let's go by ones on here. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so let's graph A. We've got 0, 4. We've got 1, 11. We've got 2, 18. So 2 goes up to 18. So if I connected these, I'd get this line. Okay, well that's A. Let's do B. B is 0, 0, 1, 7, 2, 14. 2, 14. Connect those. So there's B. All right, C, we've got 0, 7. Let me change to a different color. Sorry. 0.07 right here. 1 and 750 is going to be right between the 7 and the 8. So 1 and then 750. 2 and 8. So this guy is going like that. That's C. Now the last one, 0, 0. So we've got a dot right on top of that. 1 and 2. 2 and 4. So this guy is going to go like this, and this is D. If you notice, which graphs represent relationships that are proportional? Well, look at the 2 that came right here. I've got B and C coming right through that origin. So again, B and D go right through that origin. And so those are the 2 that go through. And how can we take a look? We can, because B and D go through the origin. All right, so let's talk about pizzas again. We're back to Mario's Pizza. Mario's Pizza sells medium pizzas for $5.50 and $1.50 per topping. So if I don't buy any toppings at all, I'm just going to pay the $5.50. So I know that I'm just going to do $5.50 plus 0 toppings, that's $5.50. I know I'm going to pay $5.50 for the actual pizza, like for the pizza itself. Then I'm going to pay 1 times $1.50. Remember, multiplication comes first. So 1 times 150 is 150. 150 plus 550 is $7. All right, let's take a look at 2 and 3. I know I've got to pay $5.50 for the pizza itself, plus I've got to pay for 2 toppings. Well, each topping's $1.50, so 2 times $1.50, that's $3 for the toppings, and another $5.50 just to buy the pizza, so that's $8.50. So we've got $5.50 for the pizza. This time we're buying 3 toppings. So we've got to buy the 3 toppings. Each one's $1.50. So 3 times $1.50 gives you $4.50. Add that to $5.50 and you get $10. So let's go ahead and graph that. So if we have number of toppings, we go 1, 2, 3, 4, 5, 6, 7, 8. Now let's go by, let's see, $10. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 toppings, or sorry, $10 here. So this is all dollars, and this is the number of toppings. So when I'm at 0 toppings, here's 0 toppings, I'm at $5.50. So 0, 1, 2, 3, 4, $5.50. When I'm at 1 topping, I'm at $7. When I'm at 2 toppings, I'm at $8.50. And when I'm at 3, I'm at $10. Now, is this a proportion? Absolutely not. It does not go near the origin, so not a proportion. So let's talk about the function rule. Let's say that price is P and number of toppings is N. Okay? So it's always going to start with this equals, so the price is equal to, well, let's see what stays the same. $5.50 stayed the same, so let's bring that down. The plus sign stayed the same, and the $1.50 stayed the same. This guy's the only number that varied, or the only number that changed. This is the number of toppings. Number of toppings is represented with N. You've got to ask yourself, is this the real way to write this? Not quite. So the price is equal to $5.50 plus $1.50 per topping. If I wanted to write this in function notation, all I would add, I'd write the same exact thing again. The only thing I'd add is this N in here to let them know that the price depends on the number of toppings. The number of toppings is in charge of what the price is. So this says, does this situation represent a proportional relationship? No. Because look what happens. If I put something in this machine, it gets multiplied by $1.50 and then added to $5.50. So no, it does not go through the origin when we graphed it. and there's more than multiplication going on. So that's perfect. More than multiplication going on. All right, so let me make a second video for, whoa, wait a minute. What page am I on? 233, wait, 230, 240, 241, okay. So we've got to do it again. Let me go ahead and make a second video for this one.